is my second task submission for the internship at the Sparks Foundation. This task 2 is prediction using Supervised ML. As a first step, I'm importing all the required libraries. Here I'm using linear regression model as the dataset has only 2 variables. The dataset is available at this URL from where I'm loading the dataset. I'm printing the dataset, the first 10 rows. There are only 2 columns available. One is the hours studied by a student and the second column is the scores secured by the student. So our task is to predict the scores based on the number of hours studied by the student. For data analysis part, I'm checking if there are any null values. There are no null values. Hours and scores, there are no null values. I'm plotting the data set hours versus percentage. As you can see, as the number of hours studied is increasing, the percentage score is also linearly increasing. Now I'll prepare the X data and Y data. X data will contain the features of the dataset, and Y data will contain the target variable which we are going to predict. So in X data, I'll take all the rows and the columns excluding the last column. And for Y data, I'll take all the rows and the last column, which is a score. So X data will contain the number of hours and Y data will contain the scores. Now the test size is 0.2, which means I'll be taking 80% of this X data for training purposes and 20% for testing the model. So I'll split using train test split, and I'll be getting X train, Y train, X test and Y test. If I'm checking the length, I'll be having 20 samples for training and 5 samples for testing, which is the 80-20 ratio. Now I'm instantiating the linear regression model and feeding the X train and Y train to the model and fitting the model with that data. Once the training is completed, I'm getting the coefficient and intercept from the model and plotting the regression line. So these are the actual data plots and this is the regression line. Now I'll create a data frame with the actual actual test marks and the predicted marks. So first I'll predict the marks using the model and the predict function. I'll feed the test data, which are the 5 samples, into the model and predict the model. So these are the predicted marks. I'll compare the predicted marks with the actual marks. So if I see there are 5 values for actual and predicted, there are not much difference. It's almost predicting correctly. Now I'm just going to predict how much is the score scored by a student who studied for 9.25 hours. For that, I'll create a variable number of hours studied 9.25, convert it to an array and use that to predict the marks on prediction. So for a student who has studied for 9.25 hours, my model is predicting that his score will be 92.38. To do a performance evaluation, I'm printing 3 matrices. One is the mean absolute error, which is the difference between the actual score and the predicted score. That's only 3.92, which means the model is performing well. Then mean square error, which is we are calculating the errors, square it and then do the average. That's a mean square error. Then R square. R square will lie between 0 to 1. A value closer to 1 indicates that the model is performing really well. So here it is 0.96, which means this model is performing very well. Thank you.